In the vastness of space, more than 24 billion kilometers from Earth, a tiny probe drifts alone, Voyager 1. It is humanity's most distant outpost, a silent ambassador on an interstellar odyssey. Since its launch in 1977, Voyager 1 has traveled farther than any machine ever built, pushing beyond the boundary of our solar system and into the unknown. Out there, where the sun is but a pale point of light, it whispers homeward across unimaginable distances, its faint radio signals racing past planets and stars to reach the antennae of Earth. But what happens when those whispers finally fade? When, after decades of astonishing discovery, Voyager 1 falls silent? What does that moment mean for science, for exploration, and for our place in the cosmos? Voyager 1's journey began with a singular mission: to study Jupiter and Saturn, the gas giants that dominate the outer solar system. Yet, as each milestone passed, and Voyager's instruments continued to send back data, NASA's ambitions grew. The spacecraft's 4-year mission stretched into decades. Its power, generated by the slow decay of plutonium-238, has kept it alive long past its expected lifespan. Now, almost half a century since launch, Voyager 1 continues to beam home data from an environment no other probe has ever visited, the interstellar medium, the region beyond the influence of our sun. But time is relentless, even for legendary explorers. Voyager 1's power supply is dwindling. Each year, its radioisotope thermoelectric generators produce a little less electricity. To preserve energy, NASA engineers have already deactivated many of Voyager's scientific instruments, carefully rationing its remaining power for the most essential systems. The process is meticulous, almost surgical. One instrument powered down, then another, each a step closer to silence. There will be no dramatic finale, no explosive last transmission. Instead, Voyager 1's end will unfold as a gradual fade. Its instruments will shut down one by one, their silence accumulating in the darkness. First, the scientific payloads will go quiet, then the engineering systems, until at last only the basic functions remain. Even these will eventually succumb as the power levels drop below what's necessary to operate the spacecraft's transmitter. As Voyager 1 drifts farther from Earth, its radio signals grow ever fainter. Our most sensitive listening posts, the massive dishes of the deep space network, strain to detect its final echoes, sifting through cosmic static for the signature of an interstellar traveler. Ultimately, there will come a point when Voyager's signal is indistinguishable from the background noise of the universe. The probe may still be transmitting, but its voice will be lost in the cosmic sea. Communication will cease, not with a bang, but with a whisper that fades into silence. This quiet end carries profound scientific consequences. Voyager 1 is the only spacecraft operating outside the heliosphere, the bubble of charged particles blown by the sun. Its sensors have revealed the true nature of interstellar space, measuring cosmic rays, magnetic fields, and plasma waves in a region previously beyond our reach. Its data has helped redefine our understanding of the boundary between our solar system and the galaxy at large. When Voyager 1 finally goes silent, we lose our only direct window into this mysterious realm. The flow of real-time measurements will stop, leaving us to rely on the archives of data it has transmitted and to dream of future missions that might one day follow in its path. Yet, even as its voice fades, Voyager 1's journey continues. On board, it carries a message, a golden record, etched with sounds and images from Earth. This time, Capsule, created by a team led by Carl Sagan, contains greetings in dozens of languages, music from around the world, and snapshots of life on our planet in the late 20th century. It is a greeting to the cosmos, an offering to any distant intelligence that might one day encounter this lonely craft. Even after its systems have failed, Voyager 1 will sail on through the galaxy, bearing this message across the ages. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, deep in the constellation Camelopardalis. By then, it will be utterly mute, its instruments long dead, its circuitry cold. But its legacy will endure, not just as a testament to engineering, but as a symbol of humanity's urge to reach beyond the horizon, to ask questions, and to explore. The end of Voyager. One's mission is not a failure, but a triumph. For decades, engineers have performed extraordinary feats to keep it alive, reawakening dormant thrusters, diagnosing faults across billions of kilometers, adapting to challenges that no one could have predicted when the probe first left Earth. Each act of ingenuity has drawn out its life, giving us precious years of discovery. When the last signal finally fades, it will mark the conclusion of an era in space exploration, but also the beginning of a new chapter, one defined by the knowledge and inspiration Voyager 1 leaves behind. In the silence that follows, the data gathered by Voyager 1 will continue to shape our understanding of the universe. Its discoveries have already changed how we think about the solar system, the interstellar medium, and our own place in the galaxy. The legacy of this tiny probe, drifting through the darkness, is measured not just in kilometers, but in the generations of explorers it will inspire to reach even farther. Yet, as inevitable as the fading of a distant star, Voyager 1's journey is approaching a new phase. NASA engineers estimate that by 2030, the spacecraft's energy reserves will dwindle, no longer able to power its scientific instruments or communication array. Some engineering signals may persist for a few years more, perhaps until 2036, but the end will not be marked by drama. Rather, it will come as a gradual dimming, a slow, methodical powering down of systems, one by one, as the plutonium-238 that has fueled Voyager's heart for decades finally loses its warmth. There will be no final emotional farewell. There will be no last triumphant burst of data. As the power supply drops below critical thresholds, each scientific instrument will cease its observations. The plasma wave detector, the cosmic ray sensor, the magnetometer, each will fall silent in turn. Eventually, the main transmitter will lose its ability to reach Earth. The signal, once so strong it could be received by a backyard dish, will fade into the static of the cosmic background. At last, the deep space network, our planet's great ear turned toward the cosmos, will hear nothing but the faint hiss of the universe itself. This silence is more than symbolic. When Voyager 1's radio voice is lost, humanity will lose its only active outpost in interstellar space. No other probe has crossed the heliopause, the boundary where the solar wind yields to the interstellar medium. For years, Voyager 1 has provided unprecedented measurements of cosmic rays, magnetic fields, and plasma density from a domain never before sampled. Its loss will leave a unique gap, a pause in our direct ability to sense and study the environment beyond our sun's influence. But even as its instruments go dark, Voyager 1's odyssey will continue. The spacecraft, now inert, will become a silent traveler, an object enduring in the vacuum, gliding through